Okay, so this is the second part. So this is we're on page 352, where it says tabular integration. Okay, tabular integration. Okay, so I'm going to go ahead and teach you this with the caveat that this is kind of a shortcut. Okay, this is a pretty nice trick. The problem with this trick is that the shelf life on this is about a week or two. A week or two later, you will forget this. Okay, hopefully you'll still have it during the test, but we'll see. Okay, so this is what we call the tabular integration. Okay, earlier when we did x squared e to the x dx, and we did the substitution, we did the integration by parts twice to go from x e to the x to x squared e to the x, and then the next time it was x e to the x, then we actually got the solution, right? So I'm going to teach you how to do this. It's called tabular integration, okay? So we take the first, this is one of our functions, and this is the other function, okay? On this side, we're going to differentiate. On this side, we're going to integrate, okay? If I differentiate this, I get 2x. If I differentiate this again, I'm going to get what? 2, and then I get 0, right? If I integrate this, I get e to the x, e to the x, e to the x, okay? So here you go. This is what we do. We're going to go like this plus this minus this plus, and you keep on going down like that, okay? So this becomes x squared e to the x plus minus 2x e to the x plus 2e to the x. Then obviously we have the c. And this is your answer. Pretty darn simple, right? Okay, the problem is there are several ways to mix this up, okay? This side you have to differentiate. This side you have to integrate, okay? And on this side, now you multiply it like this, where you go positive, negative, positive, negative, positive, negative, you go down that way, okay? So this is the answer, and you're done. Okay, again, the problem with this is that there are many ways to make a mistake here, right? Differentiate this side, integrate this side, then you go ahead and go cascade this way, positive, negative, positive, negative, positive, negative, and so on and so forth. Okay, so this is the tabular integration. Okay, again, this is a quick, dirty way to do it, yet you still have to remember how to do the by parts, okay? All right, so that's example number 5. Let's go to example number 6. We'll do one more. This will do another tabular integration. And this time we have x to the 3rd sine x, x to the 3rd sine x dx. So again, x to the 3rd sine x. So let's differentiate this down. I get 3x squared, 6x, 6, 0. Now I have to integrate this. Okay, so integrate this, what do I get? I'm going to get negative cosine x, negative sine x, right? Now if I integrate that again, what do I get? I get cosine x. I do it one more time, I'm going to get sine x, right? So in other words, if I differentiate it up this way, I would get this, right? So I differentiate this, I get this. If I take the differentiation of this, I get this, this, and I'm moving up that way, right? So now I'm going to go like this, positive, negative, positive, negative. So I get this guy, so it's going to be negative x cubed cosine x. This side of the negative cancels out, so I get plus 3x squared sine x plus 6x cosine x minus 6 sine x plus c. Make sure I got that right. It looks like we're good. Okay, again, you see how it's pretty complicated here, okay? Although you get this nice and easy in one fell swoop, there's a lot of work to be done here. Okay?
Does it always work?
So basically, when are you going to use this? Most likely, when are you going to use this?
When I'm stuck.
High-powered polynomial here, right? And you want to kind of cascade it down. This is when you would end up using this guy. Does that make sense? Or this guy would just kind of fluctuate back and forth, and you know, whatever you get here. Okay, does it always work? Would it work for e to the x sine x? It's not going to work there, right? If I have e to the x cosine x dx, if I tried to do this, would it work?
Well, just keep on going.
You just keep on going, right? There's no end to it, correct?
But maybe there's a circular hack, like another.
So basically, you're going to use this when you notice something like this: x to the third, x squared, or x to the fourth, or something like that, and you just cascade it down. Okay. Good question. All right, let's go ahead and go back to the antidifferentiation by parts, and let's see if we can do example number 7. Example number 7 is natural log of x dx. Now we can do this by parts, okay? Except for, what's the problem? I only have one thing here, right? I don't have another one. Okay, so we're going to put a 1 here. And we're going to say that u prime is equal to 1 and v is equal to natural log of x. Okay, which means that u would have been what?
X.
X. And v prime would have been, the differentiation of this would be that, right? So this is going to be equal to this guy, which is x, natural log of x, minus x times these guys, this time this. It's going to be this times this. Cancels out, this is the 1. X, natural log of x, minus x plus c. You see how that worked? So basically, I made up a 1 here. Okay, all right. Let's do another one, the same thing. In here, it's example number 8. Example number 8, I'm going to have arc sine of x dx. Okay, so what am I going to get here? I'm going to put the 1 here. So another, again, I'm going to u prime is equal to 1, which means that u is going to be equal to x, which means that v had to be the arc sine of x. V prime is going to be equal to what? The derivative of this is going to be 1 over 1 minus x squared, right? You guys remember this? Didn't this come up in one of the homeworks? Or was it arctangent?
Something like that.
Right? So here we go. Let's go ahead and do this. So I'm going to get uv, which is this guy. So I'm going to get x arc sine of x. Then I'm going to get this times this. So it's going to be negative x over square root of 1 minus x squared dx. And I came up with this mess here, right? How would I solve this? Can I do this differentiation by parts?
Could you do like the substituting?
Exactly. So now I can do a substitution here, right? I can substitute this guy as u, then du would be what? Negative 2x dx, correct? So I created, if I divide this by negative 2, I've got this guy, which is right here. So this ends up being x arc sine of x. I have a negative 1/2, but the negative in this guy cancel. So if I put this guy in here, what do I get? I get plus 1/2 u to the negative 1/2. That's 1 over the square root of u du, right? So this is going to be equal to what? X sine negative 1, arc sine of x, and this is going to be equal to plus 1/2. You're going to get 1/2 e to the u to the 1/2 plus c, right? Because this half and this half will cancel out when I take the derivative, right? So this guy just becomes, I'm going to go ahead and now put this guy as, actually, I'm going to go ahead and put this like 1 over x squared, correct? So I'm done. And let's make sure everything's good. Oh, the one, well, this is 2. This is 2. Dang, not 1/2, it's 2, right? Because when I take the derivative of this, yeah, okay, it's 1 over 1/2, okay? So this guy cancels out, and I get square root of 1 over x squared. So the end result is going to be x arc sine of x plus 1 over x squared plus c. This guy would be your answer. Okay, so this is how you would derive the integral of arc sine. If you go to page 601 again, 601 arc sine is there. What number is it? Can anybody find arc sine there? On page 601 or 602. Where is it? Oh, it's number 46. It's number 46, where it's the arc sine of AX, where our A here would be 1, right? Okay, that's it. We're done for the day. This is